By this time we know what is SL. Now in this class we will see what happens when we connect cells in series. But first let us draw two cells connected in series. Let me say we have two cells with EMF E1 and E2 connected in series. E1, E2. Let the cell which has EMF E1 has an internal resistance of R1, and the other cell has an EMF E2 and internal resistance R2. Let this point is A, B, C. So let E1 and E2 are the EMF of the two cells. Let E1 and E2 are the EMF of two cells connected in series. Let R1 and R2 are the internal resistances. Let VA be the potential at point AB. Let V of A, VA, capital A it is, VB, and V of C are the potentials at terminals or at points A, B, C respectively. C respectively. So now from this we can write, so we have assumed some things like E1, E2 are the EMFs, R1, R2 are the resistances, internal resistance, and VA, VB, VC are the potentials at points A, B, C respectively. Now we can write the potential difference between points A and B, VAB. The potential difference between points A and B, VAB, will be equal to V of A minus V of B. And we know this is, if a current I is flowing, let me say this EMF is connected to external circuit and a current I is flowing. So if this is the case, then VA minus VB is nothing but that is the terminal voltage of the cell 1, which will be equal to E1 minus I1 into R1. Similarly, let VBC be the potential difference between points B and C, which will be equal to V of B minus V of C. This is again equal to E2 minus, here there is nothing like I1, so it is I only because we took the current as I, minus I into R2. Now the potential difference between the terminals A and C of the combination will be the potential difference between the terminals A and C of the combination will be VAC. Is equal to VA minus VC. VA minus VC, which I can also write it as, this VA can be written as, so this whole thing I can write it as VA minus VB this I will just write it as V of A and V of C, because we took, instead of V suffix A, I took it as V of A minus V of C. So this can be written as equal to V of A minus V of D. I am just adding and subtracting V of B plus V of B, and hence the equation remains the same. Just add and subtract V of B for this equation. Now this can be written as V of A minus V of B and V of B minus V of C, and we know the value of this. VA of A minus V of B is nothing but E1 minus I into R1. V of A minus V of B, we already have it as E1 minus I into R1. Plus V of B minus V of C equal to E2 minus I into R2. So E2 minus I into R2, which is equal to E1 plus E2 minus I into R1 plus R2. Now let us say we wish to replace the combination by a single cell between A and C. Now we have two cells between A and C. Now if we wish to replace it by a single cell between A and C with one EMF, that is E equivalent, and internal resistance R equivalent. Let me draw that network. So if I wish to replace this whole combination by one EMF with internal resistance R equivalent, this point is A, C, this is E equivalent in series with R equivalent. The whole combination we are replacing by one cell. Then what happens? Take this equation as equation 1. Now you write, if we wish to replace the combination by a single cell between A and C of EMF, what happened? Just one second. if we wish to replace the combination by a single cell between A and C of EMF E equivalent of EMF E equivalent and internal resistance are equivalent, and internal resistance are equivalent. Then we will have like VAC is equivalent to E equivalent minus I into R equivalent. Now we combine equation 1 and 2. What do we get? Comparing equation 1 and 2. Compare equation 1 and 2. Comparing equation 1 and 2, we can write E equivalent is equal to E1 plus E2. And R equivalent is equal to R1 plus R2. So if we have two batteries connected in series, then the net equivalent will be sum of 2. So if we connect the cells in the reverse way, for example in this way, this is E1 R1, E2 R2. So in this case E equivalent will be the difference between two EMFs, E1 minus E2. So negative electrode of one is connected to the negative of the another one. If we connect two negatives, then E equivalent will be the difference between the two EMFs. So the rule for series combination is clearly the equivalent EMF of series combination of n cells is the sum of EMFs of the individual cells, and the equivalent internal resistance will be equal to the sum of the internal resistance of each cell. Similarly, we can get the equivalent EMFs and equivalent internal resistance when the cells are connected in parallel. So in the next class we will see about cells connected in parallel.